Now the next presentation is for Anat Caspi from University of Washington. Her communication is accessible mapping is a network problem, access map, open sidewalks, and sidewalk score. Caspi receives her philosophy doctor in bioengineering from the joint program in bioengineering at University of California at Berkeley and UC San Francisco, and her master and bachelor in computer science from Stanford University. Her research interests are in the areas of computational biology, ubiquitous computing, and bioinformatics. Before returning to academia, Caspi spent a decade in the medical and laboratory device industry. Anat Caspi is director of the Taskar Center for Accessible Technology. This initiative is housed by the Paul G. Allen School of Computer Science at the University of Washington, is focused on translating novel research and technologies for use by populations with disabilities.
Hello, I'm so excited to be here. First of all, that Carlos even found me, but secondly, that I kind of feel like we're in a close space here of the 20 people in the world that agree with everybody here on some issues having to do with urban accessibility. So some of my talk is somewhat moot because a lot of times in the US, I talk about accessibility and I have to start from pretty much zero in terms of, for example, accessibility being a non-binary label. So what does that mean, accessibility is non-binary? We've talked a lot today so far about how access has to do with personal preferences, needs, and requirements about the infrastructure that's available there. And so when Google, they have a crowdsourcing mechanism that asks people to rate different places about accessibility. And they ask people who are untrained and not really familiar with accessibility issues to label a location as accessible or not accessible, hence the binariness of that label. And as we know, that's really not appropriate. Everyone here has pretty much talked about that. So I'll kind of skip through that, but note places in my talk where that becomes a factor in the tools that we're building. Secondly, mobility is not transport. So personal mobility has everything to do both with the infrastructure that's there. What does urban infrastructure provide us? And also, what are the tenets of the population that's trying to access it? And of course, as we're looking at heterogeneous populations, we have to take into account all of these factors that have to do with personal mobility and access to different amenities in the environment. And so the projects that I'll talk about today are Open Sidewalks, which is all about developing a pedestrian-centered transportation layer and an open data standard to describe the pedestrian network. So many of us here talked about the need for a pedestrian layer and an actual geographical information layer that's connected and describes the connectivity of how paths are connected on ground. What we're proposing is to actually have standardized mechanisms to both consume and provide this kind of data so that people can share that kind of information. We find that a lot of the institutions and stakeholders that we work with have particular interest in the pedestrian infrastructure, but don't have the money or resources to actually do this kind of annotation on an ongoing basis. So maybe they got, in the US, you're probably familiar with the American for Disabilities Act. That's something that made cities responsible for collecting pedestrian information and have an actual location where people can go and find out information about sidewalks, but none of it is a graph network of the pedestrian layer. It might be something like Excel spreadsheets that will list out, oh, this sidewalk is present. It was last visited in 1984. We gave it a license to create a curb ramp in 1960, you know, but nothing about the geographical location and connectivity of those sidewalks. And that's what's so pertinent to all of the tools that we're trying to provide to individuals, both to do A to B navigation, as well as providing institutions with and urban planners and transportation planners with the ability to do sort of global analytics on what does the infrastructure actually have here in terms of the mobility of an individual who uses a cane, an individual who uses a particular device like a wheelchair or a powered wheelchair, etc. Am I talking too fast? Okay, thank you. So to advance a smart non-motorized mobility in the smart city today, we have to take into consideration the ability to look at mobility as a personalized asset. And what I mean is, a lot of smart cities are now really targeting trying to push people to using public transport. I'm very US centric in this regard, in the sense that a lot of European cities have already been doing this for many, many years. In the US, there's still that American dream that associates the use of a personal car with social mobility. And we're trying to dismantle that kind of ethos. And in order to dismantle that kind of ethos, we need to make walking and walkability an elevated asset and something that is desirable. We want to make walkability something that people want to do. And to do that, we don't currently provide people with the tools to do that. We don't have a mechanism to navigate in Google Maps for a pleasant walk. It's only the shortest path. And the shortest path is oftentimes not a very pleasant walk. It will lead you up like unimaginable hills. It will lead you up streets with no infrastructure, no sidewalks whatsoever, because of the prominence of auto-centric mapping and the fact that no one, even Google, even though they have that data, have not actually created the pedestrian layer to support this kind of tooling. So when I come to Google and I ask it, give me a pleasant scenic walk, there is no such feature because they have no idea of where the sidewalks are. And we actually did a recent study with a usability study with individuals and showed them how using a network structure, they can actually start asking these kinds of questions. And people basically agreed that they've been poorly trained by all of these, commonplace digital cartography tools to look at ourselves as slow-moving cars, which we are not. So as non-slow moving cars, we need to advance the tools that are out there to allow us to make really personal decisions about our mobility in space. And as such, this becomes not just an accessibility problem. It's not just about having a wheelchair and having the path wide enough. It's really about respecting the fact that we all access the environment in very different and personal ways, and that we now have the digital tools to support people actually making those informed decisions in digital cartography. So mobility is really the joint expression of individual likes, abilities to move in real time through physical space and within diverse environments. I will skip this, but I want to focus on three main questions that I would like to ask, that our tools would like to ask, and why we should start talking about an open standardized data set that could actually support providing all of these tools. So the Tasker Center is a very participatory design focused center. We work with communities of practice. We talk to people about their mobility, about independent mobility, and their access to work and play. So initially, we talked to people, well, what are your needs? And initially, they just said, well, how do I find safe, accessible routes that are tailored to my personal abilities? But as we looked at other stakeholders that might want to partner with us, we found the on-demand transportation and mobility institutions to be very much interested in these kinds of questions. We talked about audits. In the US, there is a law that every transportation agency has to provide paratransit services that are equitable to the services that they provide using the scheduled bus system. To provide somebody with basically an on-demand taxi from their home to where they're going is actually a very expensive proposition. So cities typically pay 40 times the amount for a single onboarding of an individual on the paratransit services as they do for the scheduled bus system. I don't know the economics for other locales, unfortunately. But what that means is that when an individual asks for a ride, somebody from the paratransit services has to come on board. It's usually an expert. They come and they survey the environment. And I believe somebody here today spoke about this kind of audit, the expert audit. But they do a lot of activities that are expensive and non-leverageable. Basically, if I call today and I say, I need to get from here to point B, please help me because I can't access my scheduled bus route nearby, they'll come and they'll assess the location based on my mobility. And then tomorrow, if my flatmate calls and asks for the same exact route, but their limitations are different, the auditors have to come back again in order to write a report that's specific to the second individual. And so they can't really leverage the work that they're doing, which makes it expensive. And there are long wait times. People can't access their work and they can't access their schools. It's a very difficult problem. And so those are the kinds of problems that we think we can actually resolve to some extent using standardized mapping methods for accessibility. The last question that I'll talk about today is about with city and transportation planners. They want to know how to prioritize non-motorized infrastructure investments so that they can maximize utility for the heterogeneous population that they're serving. So if they're asking, where am I going to put this bus station? They are asking questions of isochrones, like we've seen earlier today. How many people can reach my station within 5 minutes? And currently, they're using very arcane methods to calculate this. Some of them are even using like bird of flight methods, within 5 minutes. And we know none of us fly anywhere yet. And so it's not really a good way of collecting information about how many people can access this bus station if you say, oh, just my, half-mile radius or something like that. We need to actually know where people can walk or mobilize with chairs, etc., to understand what is the real reach of these transit locations. So we started looking at what are those attributes. There have been a lot of studies done with individuals with disabilities to understand what are some of the barriers that they would want to know about, where are some of the informational gaps that occur. So some issues are permanent, like stairs and steep hills, and others are transient, like construction, noise, things that pollution, air pollutants like seasonal pollen, things like that, might be transient. And so for now, we're really just addressing the static type of data, but we're looking into how we can house the transient data as well. So OpenStreetMap is kind of the infrastructure that we're using. A lot of people here are familiar with it, so I won't go into the detail. But really, the community only supports static kind of data, and for good reason, because transient data is really hard to describe and hard to maintain. Because if you have a community maintained tool and construction is put on the map, who knows when to take it off, right? And there's not really a good way of moderating that. So we're trying to figure out good ways of doing that, but right now we're not yet addressing that, at least not in OpenStreetMap. We do in our own servers because we do collect this kind of data. So for example, we know where construction is, but we keep that siloed, unfortunately, because we try to manage that temporality of the data. Okay. So as I said, we use a participatory design approach, and we talk to a lot of people and try to understand what are the challenges in using the current digital cartography tools. But I should say that this is a much more personal issue for me as well, because my daughter uses a wheelchair, so I actually get to test this stuff first. And oftentimes I get to say when the data is good enough or not. And usually that's really important for the kind of community relationships that we have created, because people tend to trust the data if they know it's been vetted before. So the access to reliable pedestrian-centric information about paths has been a really critical challenge to us. Seattle is known as a very open data place, and the Department of Transportation has a ton of data. They did a hackathon. They were really open about all this data, and we took all the sidewalk data that they had, and it was horrible. It was absolutely horrible. Somebody here was talking about the 3 meters closest to, they don't even know the start and end locations of their sidewalks within 10 meters. On occasion, they will put the sidewalk on the opposite side of the street. So no connectivity there, no geometrical information that was reliable to take. So the next approach we did was to actually use something similar to what you described by taking the auto street network and just inferring where the sidewalks might be. And so we made some inferences, and it worked, but it wasn't accurate to the point of a lot of neighborhoods don't have sidewalk infrastructure, or many places might have sidewalk infrastructure, but only on one place or another. So then we ended up doing 2 methods, which was inferring from the OpenStreetMap road network, but then using individuals to vet the information as a further layer of annotation. And so the kinds of things that we wanted to know while they were vetting this information were, where are the curb ramps, where are the time signals or the accessible pedestrian signals, where are some partial blockages that might encroach on the passage in the infrastructure. We also wanted to know about some positives. So for example, curb bulbs are really good mechanisms of slowing down the drivers and also providing more visibility to individuals who are waiting at the curb. So these are some assets of the environment that we wanted to highlight as a positive, because the whole time, and I'll tell you the whole, the way we started along this mobility project had to do with an autonomous wheelchair project that we have. And all we really wanted to do was to have the wheelchair contact our API and ask for a route, and a wheelchair accessible route from point A to point B. And we thought this would be super simple. We'll do the data stuff in a weekend and we'll move on to working on the wheelchair robot. And of course, we have been working on this for 4.5 years now, realizing that the data is not there and we need this data standard. But we're getting a little bit closer, and I'll show you some of our results in a minute. But the point with the wheelchair was that we wanted to also highlight the cost function that an individual with a mobility limitation or a vision limitation might use in the environment, both as a positive cost as well as penalties, so that the infrastructure can really help us in terms of provisioning the most accessible route to this individual. And that's why we're looking at assets in the environment, not just that are barriers, but also things that are helpful to mobility. So Open Sidewalk is all about saying that with the right kind of data, we can address real and immediate needs, and we can gather this data quickly using some established framework. We didn't want to start our own servers. I don't have the mechanism to support databases at large. And so, as I mentioned, we're looking at these aspects of the environment, but we really do want to have very specific, detailed information to avoid those accessibility yes, no kinds of labels. So we're not going to ask people, is this accessible, yes or no, because we say people don't have that ability to make that assessment, given that they don't know who's using this. So even if they know a person with a disability super well, they're only going to assess the environment with the lens of that knowledge, and not sufficient knowledge to really address the needs of everyone. So we created a flexible data model. We're still working on it. We're currently working actually with the paratransit services in Seattle. So we're working with their auditor team to describe to us more of what it is that they audit when they look to see if a path is accessible from a person's home to the nearest bus station, so that we can include more and more details about the environment. I see this as a progressive data standard, really. As it starts out, it's really just about geometries, much like was described earlier by other projects. We're super interested in just having the layer, where are the sidewalks and how do they connect? That's the most important asset. But on top of that, we have to give sidewalks their own entities, which OpenStreetMap has not always done. OpenStreetMap has traditionally asked people to just annotate as a tag on top of a road to say, oh yeah, there's a sidewalk on the right, a sidewalk on the left, or both. But that's not sufficient information to give people the kind of granularity that they need in order to really figure out what they're going to meet when they get out there, right? And so it's all about giving sidewalks their own entities, and then we're able to, with time, add more and more tags as we see fit. And so the point about this slide, which is a little bit dense, is that we are really trying to work with a whole host of different stakeholders and institutions. And my hope is that we'll create some partnerships here as well, because there's a lot of tooling that needs to happen for these kinds of data to become exchangeable and consumable by different stakeholders. But the more stakeholders buy in, the more rampant this transition into more accessible mapping can be done. And it's a big undertaking to do all of this as a single institution or a single lab or a single anything. But if we can find collaborative points where different stakeholders are contributing, either contributing data or contributing different kinds of tools, I think that's really the way we're going to get there. Because otherwise, there's no human genome project happening for that pedestrian mapping project, though I wish to see that eventually. So we've bitten like a really tiny part of this, and I'm hoping that we can engage more partners in this. So far, we have mapped Seattle, and then individuals separately, completely separately from us, but using our tools, have mapped San Jose, California. We've also mapped Bellingham, Washington, and Mount Vernon, Washington, using crowdsourced information. And the reason it's important is because the San Jose self-mapping was done by the transit agency. So they saw an interest in having their data in OpenStreetMap, which is rare for a transit agency because they're so Esri focused. So just that was a win in and of itself, but then having them actually commit to the data standard that we were proposing and putting in OpenStreetMap was important as well. The reason to focus on Bellingham and Mount Vernon, who I assume none of you have heard of, is because none of you have heard of it. The point is that there are many rural urbanities that are out there where people with disabilities and having different access related needs need that kind of information. And so if we only focus on like the huge smart cities, that leaves a lot of locales unfurnished, basically, with data. And so part of the project is to tool communities to enable them to self-map so that even in small rural communities, you can make use of the end tools that we're going to describe. And so finally, a project that we're currently working on with the paratransit services is using computer vision techniques, using the crowdsourced imagery to do the mapping. This is, I could not bring a video today due to Wi-Fi issues, but go ahead if you want to look at our video of basically what the computer is doing to identify the potential barriers in the infrastructure and also calculate the exact GPS location of where it might be. And so right now what this histogram is showing you is to the nearest meter, how close are we really? So the top layer of the video is using an actual depth camera, and so that's our validation. This is the gold standard that we're validating against, and here below is the monocular vision of crowd-contributed imagery that allows us to assess like how well are we going to do with real information given to us by real people and not Bing or Google. You're probably wondering like, why aren't we using just Google Street View? And the main reason for that is licensing. So Google does not allow derivative information from any of its imagery to be publicly opened and shared, or we'd have to pay for it. So I don't want to put OpenStreetMap in that kind of position. None of us do. Recently, Bing has actually opened its imagery to OpenStreetMapping. So It's a fresh new world for us, and we're trying to use their imagery as well. And so finally, the take-home point is trying to create flexible data models that can grow with time and needs, having all parties know where to retrieve and submit that data, and then making sure that it's scalable and could be self-mapped by communities. And those are all very important tenets to our project. So I wanted to demo Access Map, and again, since I can't be live, I'm going to give you this canned demo, but you can go to accessmap.io and have your own demo. So given that data, now we've mapped everything with open sidewalks, what can we do with it? So an individual comes and says, well, I use a wheelchair, a power chair, or a cane. And then they want to know how to get from point A to point B, but first they specify some aspects of their personal mobility profile. So they tell us, well, I would like to avoid uphill steepness of about, in this case, 8%. And then it gets really scary going downhill if I'm going above 10% downhill. And also, I would like to require curb ramps or not. In the past, we've furnished construction information and things like that. What's important about the customization of this is that we don't yet have really good UI to extract that information from people. So we're working on that, but I won't talk about that today. But the general population, if I say to you, what's your maximum uphill incline? Well, you don't actually really know. People in Seattle know this because it's so crazy over there in terms of mobility. But in many locales, people don't have that kind of constraint and don't keep that in their heads. So that's a whole UI issue and conversation about that. But assuming people can actually enter that, and they can actually play with the parameters, so they'll see how the sidewalks will change color as they change the parameters. So if I go too far and this sidewalk says, oh, now it's inaccessible, I can ratchet that back because I know I can traverse this sidewalk. So you can kind of play around with the parameters, and the reactive interface will give you a gauge of how well you're doing in terms of ratcheting your preferences. So once you've ratcheted your preferences and you give the starting and end points, you ask for directions. And there's an issue here also having to do with the time of day. This has everything to do with our participatory design community, because they told us that when they travel in Seattle, they use a lot of indoor infrastructure. There are lots of buildings where you can enter at one level and exit on the next level, and that means that you can avoid a hill that's like super steep. But it depends if the building is actually open at that time. So we had to digitize all of that data in order to make this a really functional tool for that community. And I think a key point here is to work with the community to understand, how do locals do it, right? So once we did that, we are now able to provide a person with the path that is best for them, not necessarily the shortest path. And you'll get the trip information and some additional features about what's the steepest uphill and the steepest downhill. One thing to note about this, people always say, oh yeah, Google does that for me now. And it's true, but it will also give you a rating of like mostly flat, because they just look at the gestalt of the entire trip. And even if there is that like one hill that's really super steep, they won't indicate that to you. But I think it's really important to know, like, what's the one potential barrier in my entire trip that will kill the whole trip, right? It's not just about, well, what's the overall gestalt of this trip. So I think that's an important point. We also offer card by card, step-by-step information about the directions. So as someone had mentioned with provisioning information for blind and vision limited travelers, you want to not just say, oh yeah, go 5,000 meters alongside the northeast side of Western Avenue. You want to actually say, you want to use the northeast of Western Avenue and use this particular crossing, cross at this side, specific annotations that will help people actually assess where they are and know how many blocks they need to traverse. And then Finally, the same tool gives specific information. So you can click on any feature of the environment and it will give you more specific information of the width of that sidewalk, what type of surface it is, the exact incline, and also the name of that sidewalk. Okay, so now talking more about the tools that might be used by city planners and transit planners, we developed Sidewalk Score, which is an effective transportation analytics. And the first question is, where are these accessibility islands? Essentially, what we're asking is, how do things not connect in the pedestrian network? Now that we have this kind of detailed information about how the connectivity of this network is, are there actual blocks where I can just kind of get stuck if I'm using a chair? And so that's what we sort of surveyed and gave to the city of Seattle. And the next question was, how do we actually assess walkability? So walk score is a terrible score. We already know that. It really bases everything on the road network. And as we all know, it's not road network that determines how I can walk around. And walk score also looks at amenities, but looks at the flight distance, proximity to amenities. And so what we really wanted to look at was the pedestrian network with relation to the street network. So if there's a street network that's super dense, does the pedestrian network actually support getting around there in a real way? So we looked at what pedestrians can do, what pedestrians without steep can do without having to go up steep elevations, what pedestrians can do without having to cross any uncurb ramp locations, and then finally, what pedestrians can do without proper crosswalks, lit crossings, which can be a scary proposition in places where people drive a little crazy. So we looked at this score, and then we are basically normalizing by the street network to understand, is the pedestrian network commensurate with what the auto-centric network provides, or does it fail to provide us with the same kind of accessibility? So you can see that different and we looked at those same metrics as far as pedestrians without having to go up steep elevations, without curb ramps, and without crosswalks. So we wanted to basically assess, how is the walkshed for the average pedestrian, just looking at the average pedestrian, not even talking about mobility limitations. How is it on par with street network or much worse than the street network? And so you can see areas and entire neighborhoods that are just much worse than the street network. And I know, because I happen to live right at that barrier between the green and the red, that you just get to a place in the city and the sidewalks stop. There's just nothing there. And so then you're pushed into the street, essentially. So we tend to believe this for the general pedestrian case. And then we wanted to look for, what does it look like for a wheelchair user who has additional requirements about the underlying infrastructure. So the stereotypical wheelchair walk score essentially allowed us to make this kind of determination. And I just wanted to say that we recently published a tool that I think I can share. Yeah, so this is called our Walksheds tool. And so it allows, say, a would-be urban planner to look at, well, what does a manual wheelchair accessibility within 5 minutes of travel look like, starting at our city hall? And so that's kind of limited. And then we would say, so, and this is actually using the indoor infrastructure. And then we might say, well, for a powered wheelchair, it's probably a larger network that's allowable. So yes, that's true. And then how does that compare to what the walkability for a stereotypical walking individual? That might expand things a little bit more or less. And the reason is that, sorry, I wanted to show the disparity between the power chair and the walking chair. And the walking individual. So the walking individual actually has the And the reason for that is because as part of our mobility, like I mentioned before, we model access in terms of elevation. And that direction of the street actually goes very uphill. So while they can use the indoor environment to access streets that are higher or lower, because the steepness is so high, they can't either go downhill or uphill in both directions because it's so steep. So what I'm trying to basically demonstrate is that personalized mobility models are entirely a facet of how much of those personal attributes we can actually model in our mobility cross function, and how many of those multiple variables we can account for will make or break how well we can accommodate different users. So to end, we're just not flowing enough, and I'll take any questions. Oh, are we okay? Oh my gosh.
We can make the questions after.
Sure. Sounds good. Yeah.
Okay. Now the last presentation is for Carlos Cámara from San Jorge University, an architecture's open source research group. Your communication is past, present, and future of accessible Zaragoza study case and collaborative mapping for the integration of empowered people. He is an architect by the Universitat Politècnica de Catalunya and philosophy doctor on information and knowledge society by the Universitat Oberta de Catalunya. He works as teacher and researcher at the School of Architecture and Technology at Universidad San Jorge, and he is a member of Urban Transformation and Global Change Lab Research Group at WOX and the Arquitecturas Open Source of Universidad San Jorge. His multiple research interests focus around the commodifications between cities, technology, and society with informationalism and free culture from, as well as the creation of maps and representation and empowering tools, amongst others.
Thank you. Thanks to everybody for your attention. In fact, I'll be the one that is going to explain this project, but it's a collab. We've been working all these people together and even more people together on doing that. And I'll try to be brief, and I will skip some part about the background and so whatever. So we've already talked much about this problem, the lack of appropriate maps that can help people with disabilities to go from one place to another, right? And we've been also talking about the physical barriers that people with disabilities are facing every day due to urban design that has not been designed taking them into consideration. And as a result, people with disabilities cannot be fully autonomous when moving through a city, especially in a city that they are not familiar with. So this project started in 2016, and at that moment, our goal was precisely to create a map or a pilot of a map that would overcome these two problems, that of routing and a map which should be capable of assessing Zaragoza in terms of accessibility, of urban accessibility, and providing a routing system for disabled people in order to go from one point to another, and also to test the required protocol and methodology to achieve this map. And when designing the project, we were based on this principle. From the very beginning, it was clear to us that it should be an open and collaborative project. And this was a political decision in terms that we believe that results of this research should be used and shared by anyone if they are to be of any use, if we are really to improve the lives of people with disabilities, results should be reused by them if they want to. And we also believed that citizens had to be part of it as well. But it was also a pragmatical decision in terms that, well, we are a relatively small team, and it was a way to overcome our own limitations in terms of staff or infrastructures that, well, you've seen that in order to make those calculations and those databases, there's a need of a very big infrastructure that we didn't have the time and resources to set up in a very reduced setup time. Okay, so as a result, we decided to use OpenStreetMap. Most of you are already familiar with it. We've been talking a lot today about that. For those who don't know, OpenStreetMap is like the Wikipedia of the maps. It has a crowdsourced approach in terms of data gathering, and data standardization. And also, it provided a way to share data both legally and technically. And because we wanted this return to this social return. We also decided to team up with others, like Mapeado Colaborativo, Miguel is there, or associations like Discapacitados Sin Fronteras or Mundo Crip. Laura Moya is here with us, and she has worked a lot with us. Ganchillo Social, administration like civic centers, and many others. Okay, this is an image of one of our second mapping party with Discapacitados Sin Fronteras and Mapeado Colaborativo with the yellow. So let's talk about the past, okay? About what we did between 2016 and 2018. And I wanted to share some procedures and accomplishments, but also some failures that we got. Talking about data gathering, okay? Well, in order to make the data gathering, we decided to create mapping parties. Just to let you know, a mapping party is like a kind of event in which many volunteers spend their time together, going to the fields and taking notes of data like this one, with pedestrian width, sidewalks width, the height of the curb, about the traffic lights, if they have signal sounds or whatever, this kind of data. So these volunteers, we gather this data with them, and we have done 5 mapping parties so far, all of them organized by Mapeado Colaborativo as well, and with those mapping parties, we gathered most of the data that of Zaragoza that we have already updated so far. In combination with that, we also started, because I didn't explain that, we started to introduce in some of them, I think 2 out of these 5 mapping parties were also part of service learning activities with and for our students of urban design and urban studies, at the School of Architecture at Universidad San Jorge. It was both a mapping party in which there were volunteers, but also we had our students who were not volunteering at all. They were there because they were going to be assessed, okay? And it was part of their it was a compulsory subject and an assessed activity, and they had to be working there. Javier Claver, that you have met him here before, was one of those students that was forced, well, not was completely forced to do this. And it was a way also to learn about technological tools like GIS, querying databases, standardizing data, but also the social implications of urban design, because after all, those students are going to be the future urban planners. So we believed that it was really important to include this in their learning activities, this kind of reflections. And we combined those students with those volunteers, and also people like Laura Moya here, or Conchita Galve, who goes in a wheelchair. So we could, like Cruz Borges, sorry, told us before, so they could test by themselves how how urban design affects mobility. Okay, so this was part of this data gathering as well. Also, we had part of our researchers did some more data gathering. They were not volunteering, they were part also of the staff. And we also started to, so since we've been improving our methodology little by little, we combined these mapping parties slowly with activities aimed to raise awareness about these problems. In this image, you can see Laura Moya and her dog, Geneva, and they were explaining to future urban planners and volunteers how she was sharing with us her experience when moving and on the city. And I enjoyed that a lot. Not only enjoyed, but as an architect, I learned a lot, and it made me think streets and squares in a completely different way. So this is one of the items that we've been adding to these mapping parties, one of the layers that we've been adding to the mapping parties. Another one, which was not planned at all, is that, well, when you see a group of people like this, who is measuring streets and so on, people usually ask questions. And we also realized that it was a good way to raise awareness about what we are doing. And the funny thing is that everybody has a saying on that. And everybody says, oh, I have my parent who goes with a trolley, or I myself, after going to the supermarket, I have to avoid this street because there's a problem there, and so on. So we realized that we're talking about accessibility, but it's not only related to people in a wheelchair or people who have sight problems, but it's something that implies, well, it involves everybody in a more or less degree. Another result out of this, after gathering that data, we created two types of visualizations, two online maps, one for visually impaired people and another one for mobility disabilities. And this is somewhat different as Cruz was talking before, because, well, we realized that it was not planned at the beginning, but we realized that different disabilities have different needs and different solutions. So we decided to split into two different maps. And this is another example. This was also an unexpected outcome. We have been attracting a lot of public attention, like TV or newspapers, because, well, it's something that it's quite shocking when you see a group of 20 people doing these kind of things. But, well, you know, not everything is perfect. We have quite some limitation. For example, our main goal was not properly achieved. We paradoxically failed to fully achieve these routing calculations. Miguel has a prototype of one neighborhood in Zaragoza, but it's not, we haven't finished our main goal. Even we created two types of map. We realized that they were not really useful because they were not very easy to understand, and also they were not visible by their audience. So we were creating a map for people who has visibility problems who cannot read that map. So it was, at this point, we were quite shocked, and we were questioning ourselves, what were we doing? And also it had, one of the problems that it had is that it had to be manually updated, because, and you know, when you have to manually update data, it means that it gets outdated very soon because you don't do it. Also, some limitations are related to using OpenStreetMaps in terms, like Anat explained just before, sidewalks are usually tagged as part of a street, and they not always, or in the case of Zaragoza, very seldom conform a good network. In fact, this has been one of the improvements after one of the mapping parties to start creating a good network of sidewalks. And it's something that we've been learning the hard way. We realize that even though it's open to everybody and everybody can contribute to, it's difficult to add information because it requires some degree of technical skills. Thank you. And also, well, some other problems related to OpenStreetMap, which we will discuss maybe tomorrow, okay? On the other hand, we had some overwhelming success or attention that we could not properly address, or we were overwhelmed by that success. So many schools have shown interest in what we are doing, but we haven't been able to do something with them like they have done before. So let's talk about what we are doing now and what we want to do in the future. So at this moment, we were just struggling and deciding what should we change about what we had done. So we started. This was mostly done by Javier Corzan there. A revision of other applications and services related to maps and accessibility. But they were different in terms of scale. Some of them were addressed to buildings, others to streets, and their aim. Some of them were just to visualize, others were to validate the data, others were for routing calculations. As you can see, some of these maps have been explained by our fellows that are here. Okay. So with this revision of the state of the art, we started to reconfigure what we were doing. So we decided that if we wanted to assess in terms of objectively the quality, the accessibility of our streets, we should be as objective as possible. We decided not to leave the data to be interpreted by the person who gathers the data, but to gather data as objectively as possible and then convert that into some type of scale or index that tells us if it's very accessible or not accessible at all. In order to achieve that, also this was mostly done by Javier. He did a very thoroughly revision of regulations related to accessibility, and he combined the national, regional, and local regulations. He summarized these three types of regulations in one single image, infographic, which explains all the casuistics, and it's really interesting to translate that into this index that we want to use. We also designed some custom-based maps for people who have problems with visibility. This was mostly done by Javier Claver there. We created two types of maps. One for people who have protanopia or deuteranopia, in which as you can see, buildings are contrasted and use some reds. We also pick a specific type font that can be easily, or we've read that it's better read. This is also another map for our tritanopia. We were testing a different type font. In this case, it's not strictly, it is mostly used for dyslexic, but we wanted also to test it. We also started to make some assessing of Zaragoza neighborhoods in terms of, so we can decide or we can quantify how accessible is one neighborhood compared to another. And we have just started today. Well, today is maybe the end or the beginning or a new beginning of a networking that we have started. We realized that we were not alone and we wanted to work with other people. We wanted to team up with other people. So let's talk about the future of our future. We have decided to keep on with the good work that we've been doing in terms of mapping parties. They are really key on this project. We've learned a lot of them and we have involved a lot of people. So this is great, and we believe that, and here Mapeado Colaborativo has a great saying on that. But we still have to improve the way data is gathered in terms of easier methodology and faster or toolset. In fact, I was impressed. I don't know if it was Anna who said you showed a map that you achieved with 4 people in 4 months. I mean, I don't know. You'll have to explain how did you achieve that, because we've been a lot more people and we have not finished Zaragoza yet. So we're doing something not as good as you are. Okay, so that's something we should improve. But we also decided to rethink or to change some other things. For example, to give a more modular approach in terms, since this is a very vast and complex field and we are not together, and we are not alone. And this workshop is a result of that reflection. We realize that there's no need for everybody to do everything. Instead, we can stand on the shoulders of giants and work together, and everybody does what it's best at. So that's, and encourage this collaboration with everybody. And also, we wanted, I couldn't explain this part, but we started as a service learning program, not a proper research program. And we slowly want to pivot to research programs that link with the history or the background of our research group, Arquitecturas Open Source, which we have a previous experience with social exclusion and urban morphology. And we believe that it would be good to just link our previous experience with disabilities, and also enhance the citizen science dimension. And yeah, that was all. I think I'm not used to talk so fast, and it's been an effort, but thank you very much to you for your attention. Thank you for Architecture Open Source Research Group at Universidad San Jorge for their support, for financing this event, and for seeding this project. To Zaragoza Accesible staff, all the people who has been working now and previously before, to Mapeado Colaborativo, because they've been really, really valuable from the very beginning. All the volunteers and associations for their data collection, especially Discapacidad Sin Fronteras, Ganchillo Social, Mundo CRIP, Asociaciones de Vecinos, many people that I can think of now. And of course, to Colegio de Arquitectos de Aragón for letting us being here and being such great hosts. Thank you very much. Okay. Yeah. Yeah. I have to.
I think this is a very good thing, because OpenStreetMap is the special support, or I don't know how we can call it, but that can help to build such projects, because it's collaborative. So it's in the philosophy of sharing our efforts for such objectives, scientific objectives. And I think that is the first time I only see OpenStreetMap as a special database.
Yeah, in fact, it wouldn't. None of this would have been possible if we weren't using OpenStreetMap. We were not being here. Oh.
I just wanted to thank you, Carlos, for bringing all of us here together. I think this is a really tremendous gathering, and I appreciate the input that everybody brought in, but especially the unifying thesis around this and what you wanted to do. So, where do you see the vision of? I mean, you gave us the future work, but what's the ultimate vision on this?
This started as a very humble project, self-learning project with no big ambition. We thought we were not very ambitious. We just wanted, to calculate our routing. Well, it was not humble at all, but we were not aware of that. And slowly, little by little, we've been learning a lot, and from the feedback and from the experience that we've been doing. So, and the project has been changing quite a lot, including. I would love to include schools. I would love. I mean, but at some point, this is something we've discussed in the group, that there's so much things to do that we cannot tackle everything, and at the end, we are architects for good and bad, for better and worse. So we wanted to reflect on that and think, well, what can we do as architects or urban planners and designers, right? It would be great. I mean, this is something we've talked informally, so maybe it's not an official point of view, but I think it would be great if we could at least attract public attention and involve public administration and in the design of new. So I would love to use this as a reflection tool or tool set to change the way how we design and live cities in a more inclusive way. Not only talking about and this subject has been studying mostly from social exclusion, something, but we would love to include disabilities, but also elderly people. I mean, I love Andrea's more wider approach, because we've been only talking about 2 types of disabilities. There are many more, and so. But I honestly don't know how to reach that goal. I mean, it's hard. We have many ideas that we can discuss tomorrow, but I don't have a clear clue on that, to be honest. Many ideas, many ambitions, but it's like at some point I'm euphoric about the wide opportunities that we can have, and then you realize that you cannot do everything. So I don't know. I don't have a real answer to that question.
Thanks, Carlos. Since we are out of time, if you don't mind, move the questions to Anat, and you can ask the questions to Carlos maybe tomorrow.
Okay.
I have some questions for. I'm going to cheat a little bit because I'm having some time since your presentation has been seeing your webpage and open site works and this type of thing. As I have seen, you are the model that you propose connects the sidewalks, but you don't connect the buildings entrance or the shops entrance of this type of scene. So you are capable of routing through your sidewalks, but you are not able to enter the places. So in the schema. Ah, okay. Ah, okay.
Because they're giving these basically sound notifications to the environment, and they guide people from the sidewalk environment directly to the entrances, giving these like tapping type of soundscapes so that you will, in the vicinity of the environment, you will approach the building. But just as was mentioned by Ms. Moya earlier, like you don't want to have multiple apps, one to get you to the sidewalk location and then an additional one to reach the door. So eventually we need to put everything together. Absolutely. Yeah, we didn't invent anything. We're just trying to bring everybody together, really. Sure. Cool. Yeah.
Question about the status of the pedestrian. You speak about a layer for the pedestrian, but a pedestrian who is in the bus is still a pedestrian. He doesn't move by himself, but he's still a pedestrian. So my question is why to choose this idea of a layer? Layer is something in GIS which is a little poor because it disconnects the layers between each others. And for me, the accessibility layer of a pedestrian is much more than what a pedestrian can make by walking. And also, a wheelchair is not really a pedestrian. I mean, he can go in a bus. Exactly. That's my question. How to connect the.
All of our pedestrian network is actually connected by nodes to the road network. The layers for bus routes is already there in some cities based on GTFS static layers that they've provided. So we can eventually get to multimodal transportation routing. For now, we just have to start somewhere, and so we're addressing non-motorized. But when I come to when I come to speak and I say non-motorized transportation, people are like, huh? So pedestrianism, I think, is an important aspect. It really describes the first and last mile of anywhere you go, right? You exit your household or whatever, and you need to get to the car, to the transit station, to the bus station, to the taxi, whatever it is. So it's more of a descriptive term, but I'll be more careful with using it. But from the equity perspective, I do think that we ought to treat all pedestrians as pedestrians, regardless of what devices they might be using. But that's my own interpretation. Yeah. Thank you.
So I let Anna-Ruth to do the farewell.
So thank you. We are very happy for having you all here. This is the end of this first international workshop on urban accessibility. We hope we can have a second event in the future, maybe here, maybe in another place. And I would like to thank all of you for being part of this event. Now we are running out of time, and we would like to invite you to another event, the presentation on a book that is the result of another research activity concerning accessibility by our colleague Ángel Comeras. And after this second event, we will meet at this square at 9:30 because we are having dinner together. So thank you all of you for coming here and enjoy the last day of the workshop.